For our next technical session, we have Dr. Peter Stabler, founder and director at SISLYNX UK, and Mr. Neill Mooney, founder and director at SISLYNX UK. They will be speaking on capability and compliance, the challenge of maintaining functional safety across supply chain.
Hello, my name is Neill Mooney. I'm a director at SISLYNX Limited, and you'll see that my colleague, Dr. Peter Stabler, is also named on this presentation. I'll be making the actual presentation, and Peter will be joining us at the end for some Q&A. And you can see the topic today is capability and compliance, the challenge of maintaining functional safety across supply chains. We have three objectives today. I'd like to explain a little bit about the concepts of SIL capability versus SIL compliance. These are terms that you won't find in functional safety standards. These are terms that we're using at SISLYNX to clarify issues around supply chain. The second topic we'd like to talk about is to recognize that the application of functional safety standards varies with SIS supply chain position. So you'll see as we go on that there are functional safety standards that address different portions of the supply chain. And we're going to be talking about what are the parts of the supply chain and which standards specifically might apply to that point in the supply chain. And what does this mean in terms of the overall integration of information across supply chains for an installed SIS? And the third point we'd like to talk about is to understand at SISLYNX how we think about integration of information across the SIS supply chain. And we think this is a critical element that is often missed. And it's critical because you cannot have functional safety and full compliance at the end user, the final installation point, unless you are successfully managing the flow of information across the entire supply chain. So let's begin with some definitions from IEC 61508. As you will know, 61508 is a generic standard that applies across industries. You have substandards, subsidiary standards of IEC 61508, which address specific industry sectors, like 61511, which addresses the process industries. And also you have other derived or derivations of 61508 that are related more specifically to specific points on the supply chain. So these definitions that we're talking about really apply across industries and across supply chain position. So let's begin with safety. Ultimately, 61508 and functional safety is concerned with achieving a safe operation of a complex engineering system. And the way that it's defined in 61508 is that safety is defined in the negative. It's freedom from unacceptable risk. So you have a concept here of, first of all, risk, and then an unacceptable level of that risk. So at its heart, 61508 is talking about a risk-based standard. And you need to understand what is unacceptable. Tolerable risk is defined as the risk which is accepted in a given context based on the current values of society. The important part here is that the context has to be specified, and the importance that has in terms of supply chain position will become clear as we go forward. So now we have two ideas of risk that we need to think about. What is unacceptable? What is tolerable? And tolerable depends on the context. Now, functional safety, which is what really we're talking about generally in this conversation, is defined as part of the overall safety relating to the equipment under control and its control system that depends on the correct functioning of a safety-related system, or SIS, and also other risk reduction measures that are being taken into consideration when defining the overall risk levels. So you have an idea here of an SIS which is being installed, which must function correctly. So graphically, we can look at these definitions. So if we start here on the right, we have unacceptable risk, which can be thought of as the starting point. This is the inherent risk in your process before you are implementing any mitigation to reduce that risk to the tolerable risk level. So what this means is if you're talking about the application of 61508, you need to have done a risk assessment of your system. And this would begin typically by looking at hazard identification, understanding what are the event sequences that will result in a hazardous event based on those hazards, determining the frequency of this hazardous event, and looking at the consequences of the realization of the hazardous event. So you need to begin by understanding what are the unacceptable risks or inherent risks, and how do you, that's the identified risk here, and what is the required risk reduction to get down to the tolerable risk level. And these are both management decisions that are made during the design process. And as we go through the required risk reduction, within the context of a process facility, you might look at process design and control, alarms and trips, and any relief devices before you think about installing an SIS that will have that will be assigned a risk reduction function. And the issue here is that 61508 is looking at this SIS that is assigned a risk reduction function. And it's asking, okay, well, what is a tolerable risk? How reliable should the SIS be to achieve this risk level? And how reliable is the SIS in reality? This is fundamentally, these are the three questions that 61508 aims to answer. And in doing so, it also requires that both the physical failures and systematic failures that would affect the correct functioning of this SIS are assessed and controlled. So we need to keep this diagram in mind as we look at the different supply chain positions, and to understand what it means in terms of achieving functional safety, i.e. the correct functioning of the SIS to achieve tolerable risk for a specific SIS system at a specific SIS supply chain stage. So the point here is that the complex supply chain associated with any installed SIS makes all of these objectives much harder to achieve. How, for example, should a component manufacturer think about tolerable risk? What is the relationship between a component and the overall SIS designed reliability and also operational reliability? How can you ensure that systematic failures are controlled throughout the entire supply chain? And at each position, how is this information shared? All of these kinds of questions make achieving functional safety much harder to achieve. And they're all related to supply chain. So when we talk about supply chain, we define at SISLYNX typically these kinds of supply chain participants. And if we go from left to right for the SIS supply chain participants, we typically begin with a component, a subsystem, or system supplier. And they develop and supply components, subsystems, or entire SIS's safety-related systems. The important thing here is that these are not within the context of the end-user location. We have OEMs, original equipment manufacturers, who develop and supply equipment and machinery that incorporates safety-related systems. So an example could be a 3D printing machine that has an SIS installed within it that monitors, say, oxygen levels and takes some action with an actuator based on a predefined set point of what is the critical oxygen level. So it's a machine that is sold on down the supply chain that incorporates an SIS. And again, an OEM will not have the information about the end use context. System integrators install safety-related systems, so they lie between component, subsystem, or system suppliers, OEMs, and the end user location. This will be a third party that comes in to design, install, and perhaps operate specific SIS loops. And the end user is the entity that specifies, procures, and operates a safety-related system. It'll always be the case that the burden of compliance with functional safety standards lies with the end user. Now, this may not be a legal requirement, but or an explicit legal requirement. But for example, in the UK, you will have a statement in the overarching safety legislation that requires that the end user, the operator of the plant that incorporates dangerous hazards, they will ask them to comply with international best practice in the design and operation of their facilities. And that typically means that compliance with functional safety standards is considered to be best practice. So this is a critical point, that the burden of compliance lies with the end user. So why is the end user position of the supply chain special? The end user is different because a risk assessment needs to consider the hazards that are specific to a particular location. And therefore, it can only be performed once the end user context is known. So, for example, you could look at a process plant that has a number of hazards that have been identified. The hazardous event sequences have been also identified, and the frequency of occurrences have been calculated for specific event realizations. But the risk is frequency times the consequence. So the consequence would be, measured in terms of the harm to operators, in terms of loss of life or injury, or it could be measured in terms of loss of equipment. So there'll be a dollar value associated to the harm. But all of these types of calculations depend on understanding which operators are there, when are they there, what's the distribution, how is equipment located relative to the specific hazard that you're looking to control with the SIS. So this is all about the end user location, and you just do not have the information to do these kinds of risk assessments until you have a deployed physical location for the SIS. This is why we talk about the first three parts of the supply chain being at best still capable. So if you followed all of the technical and management requirements of your relevant functional safety standard, these points in the supply chain, you have an SIS or a component which is able to be part of a compliant system at the end user location, but is not yet compliant. So that's why we describe these as still capable until the end user location is known. And any SIS that's assigned a risk reduction role can only be still compliant within the context of the end user location, which we've talked about. And again, still capable, still compliant are terms that we use at SISLYNX to clarify these issues. You won't find these in functional safety standards, but I think the concept is absolutely applicable across the supply chain. Okay, so if you're looking at a situation where you have a complex supply chain, and that's always the case when you have an SIS installed at an end user location, it's critical to properly define the information boundaries at each supply chain stage and to understand the associated limitations and responsibilities at that stage. Okay, so the first information boundary we're going to look at is for the component supplier. And as we've seen, the component supplier, they supply to OEMs, system integrators, or end users. And we're going to be looking at the objectives of 61508 that we talked about earlier. What is a tolerable risk? How reliable should the SIS be? How reliable is the SIS in reality? And also, how do you assess and control physical and systematic failures at this point in the supply chain? So, limitations and responsibilities of component suppliers. the component supplier will do neither a hazard analysis nor a risk assessment. So they're not able to tell their customers that their products are suitable for their SIL requirement. The second point, how reliable should the SIS be? Again, the component supplier has no information about risk. They cannot answer this question. How reliable is the SIS in reality? This data should be collected by the end user once the SIS is operational. That data can then be shared further up the supply chain. An assessment and control of physical and systematic failures. All the component supplier can do is provide failure rate data, systematic capability, and an operation and maintenance manual. So if we look at this in terms of a diagram, at the top here we have the component supplier supplying to the end user. The component supplier is still capable, end user is still compliant. The component supplier does not undertake a risk assessment. They will design to standards, and the standards are quite explicit about what needs to be done to maintain or to attain a specific level of reliability for the engineering portion of the component, but also what needs to be done from a management point of view to ensure systematic capability is maintained. So the component supplier also needs to collect this information and pass it on to the end user once the component is sold on. An information boundary for an OEM. OEMs supply to system integrators or directly to end users. In terms of tolerable risk, there is no concept of unacceptable risk in the standards. All risks are treated as tolerable. OEMs must, however, state all residual hazards and the likelihood of those hazards. They can be described as the hazardous condition, e.g. explosion, electric shock, rather than a consequence, i.e. harm in terms of the death of operators. In terms of the reliability, again, the OEM has no information about risk. The SIS, in terms of the operational reliability, again, that's collected by the end user, shared further back to the OEM once it's installed. An assessment and control of physical and systematic failures. OEMs can specify limited SIS designs for hazards within the boundary of their machine only. The SIS designs must be high continuous demand, i.e. part of the process control system only, and they should have strong functional safety management. So in terms of the machinery supplier supplying to an end user, again, they are still capable, the end user is still compliant. They have to identify residual hazards and communicate this information to the end user at point of sale. So the buck stops with the end user. They must ensure all risks are tolerable. They need to know the hazards from the OEM and use an appropriate hazard analysis and risk assessment to determine the extent of the risk. If a low demand SIF is needed, they must have failure rate data from the component supplier and design an SIS for the appropriate SIL. So information management is key. Each supply chain participant has their own path, workflow to follow. The end user needs to be informed of hazard information from the OEM and failure rate data from the component supplier. The OEM needs, where appropriate, failure rate data from the component supplier. The system integrator needs hazard data from the OEM, risk data from the end user, and failure rate data from the component supplier. And the end user may provide performance data back up the supply chain to the component supplier or OEM. So it's critical to properly manage this required exchange of information if functional safety is to be achieved. So this is what it might look like if you draw a graph of these information flows, and you can see that it's a bit of a mess. And typically this is what happens. There's a better way of managing this information, and this is what we do at SISLYNX. By employing a cloud-based central point of information collection and dissemination, you can get a lot more control over the information flow up and down the supply chain. So centralized data can be stored on the cloud and selectively made available as needed. And we manage information by supply chain stage. So here at the top, you'll register an SAS or component or subsystem, and it goes into the computer system. And the front end of the computer system app will run workflows dependent on the supply chain position and what needs to be achieved from a functional safety point of view, both in terms of engineering and also management. That links into relational database, which is, if you like, the back end of the application. And all of this takes place within the context of management processes and procedures, which assure that systematic capability is maintained for all supply chain stages. So the workflows control the path required for each supply chain stage, and management processes and procedures ensure systematic capability at all supply chain stages. So the benefit of cloud-based information management, it removes barriers to applying functional safety standards at each supply chain stage. These include the requirement for a fully comprehensive functional safety management system, transparency of the supply chain associated with an installed SIS or component parts, auditing and verification to assure that an installed SIS or component part has complied with requirements for the management of control of both physical failures and systematic failures, and scheduling and monitoring of performance, maintenance, and testing programs to ensure reliability and compliance are sustained, and live status monitoring and reporting of an installed SIS or component parts. Also field performance data for installed SIS or component parts. Okay, so just to summarize what we've talked about in the presentation, the three main points were, first of all, to understand the idea of SIL capability versus SIL compliance. And I think here we, and again, these are terms that we use at SISLYNX. You won't find these in the standards, but they are absolutely applicable to every functional safety standard at any position in the supply chain. So SIL capability really applies if you do everything properly before the end user location. So if you followed your workflows, you have managed your systematic capability, then you can say, well, okay, we're SIL capable, but you're not compliant until you are actually at the end user location and the SIS is installed and operational. And the reason for that is because the compliance part of it requires a risk assessment, which can only actually be undertaken at the end user location once you understand all of the different aspects of that context. The second point is that we've talked about the application of functional safety standards with SIS supply chain position, and it's clear that they're quite distinct, right? If you're talking about a specific supply chain location, you're applying a specific functional safety standard. You treat the risk assessments in a different way, and this is the reason that you have the idea about capability versus compliance again. And we've talked about the idea that you have to define information boundaries at the specific supply chain positions and think about how to integrate information across the SIS supply chain. So you have to, first of all, control your workflow at your supply chain position that you're at, and also the management, the functional safety management aspects that apply to that supply chain position. But this information must then be shared further down the supply chain and should be made available to the end user so that they can properly assess the low demand application for the SIL level that they are installing at the specific site location.